slope-intercept form of an equation is probably the most useful form of the equation of a line. I use it almost exclusively unless I'm doing differential equations or I have some very specific reason to do so otherwise. The slope-intercept form is y is equal to mx plus b, where m is equal to the slope as usual and b is equal to the y-intercept. So b is where this equation would intersect the y-axis, where x is equal to 0 and y has some value b. And we get this form of the equation from the point slope formula. So y minus y1 is equal to m times x minus x1. And what they've done is use this formula. Basically what they've done is they've just put in the point 0b. So with the point slope formula, we get the equation of a line by putting in a point and a slope. Here we get this equation by putting in the point 0b, and the reason it's b is because whenever in math they usually denote a random point, they usually denote it ab, where x is a and b is y. But in this case x is 0, so it's 0b. So let's put in 0b into our point slope formula. Y minus b is equal to m times x minus 0. Y minus b is equal to m times x. Y is equal to mx plus b. So that's where it comes from. It's the same thing as the point slope formula. It's just solving for a specific point. Just 0b, the y-intercept. It's solving the point slope formula for the y-intercept. That's what this equation is, and that's what it's doing. So let's use this. It's very straightforward. Let's suppose we have a slope of minus 2 and a y-intercept of, I don't know, 3. So let's use this equation. Y is equal to mx plus b. And all we do now is just put in minus 2 for m and 3 for b. Y is equal to minus 2x plus 3. And this is our equation. Real straightforward. Shouldn't give anyone any trouble. Actually, let me share something with you before I end this. This might be very useful to you. The reason I like using point slope formula, slope intercept form, I never really pay attention to what they're called. I just remember the formulas. Well, the reason I like to use the slope intercept form is it's real fast and easy to graph, and you make very minimal mistakes. And let me show you what I'm talking about. So, in order to graph a line, we need 2 points. Here, we're already given a point. So rather than say, normally in the past, what we've done to do a graph is we've made a table and we just put in 0, find out what the y is, put in a 1, find out what the y is, put in a 2, find out what the y is. Here, we already know one of the points, the y-intercept, 0, 3. So that's this right here. Now all we need to do is find one more point. And someone else might say, alright, we can just put in 1 or 2 or 4 or 10 or whatever point. But one really easy point is just to find the x-intercept. So we know what the y-intercept is. Now let's just find the x-intercept. And the x-intercept is when y is equal to 0. So I go to my equation and I just put in 0 in for y. So 0 is equal to minus 2x plus 3. Subtract 3. Minus 3 is equal to minus 2x. Now I divide by minus 2, and x is equal to 3 over 2. So I come over here and I say 3 over 2, that's 1.5, that's right here. It's a real crooked line, but I mean, you just draw a line through it. There we go, it's a little bit better. And that's it. So I've eliminated half the work. I only had to find one point because the y-intercept is already given to me. And using this, I know some people are sometimes afraid to find the intercepts because they're afraid, oh, I don't remember which is which, whether I replace y with 0 or x with 0. But here, let's say I did the wrong one. Let's say I replaced x with 0 because I forgot that to find the x. Let's say I made the mistake, say, oh, I want to find the x-intercept, and I replaced x with 0, even though you're supposed to replace y with 0. Because when the line crosses the x-axis, y is 0. Well, let's say I mixed it up and I forgot. So y is equal to minus 2, 0, plus 3. I get y is equal to 3. And I've already got that point. See, that's the thing. I'm already given the y-intercept. So if I made that mistake, I'd say, oops, I have the same point. It's the other way around. So it's also a way of guarding against errors in graphing. Because if you do make the mistake of accidentally switching them, you're just going to get the same point, and then you're going to realize that you made a mistake and then do it the other way around. So I thought I'd share that with everyone, especially if you have trouble with graphing. I found it a very easy approach to graphing, a very accurate one with very minimal mistakes, and I highly recommend doing it this way. But ultimately, you just do it whichever way you're most comfortable with doing.